Welcome to The Explainer. So, today we're going to talk about something that sounds a little bit out there. A pretty radical idea, actually, that the future of AI isn't just being built down here on Earth, but up in the cold vacuum of space. We're going to dive into some analysis that shows how reusable rockets, data centers in orbit, and our energy grid are all starting to lock together into one massive world-changing machine. So, let's start with a question that honestly sounds a bit like a riddle, right? What in the world does a rocket blasting off from the desert have to do with your electric bill? Or get this, the AI that's probably on your phone right now. It sounds like they're from different planets, but the crazy thing is, they're becoming deeply connected. And that's the story we're going to unpack. You know, the whole point of the analysis we're digging into today is this. These four massive industries, space, energy, AI, compute, they're not in their own separate worlds anymore. You gotta think of them as cogs in a single gigantic engine. It's a feedback loop, you know? A breakthrough in one, say making rockets cheaper, directly kicks off a revolution in another, like AI. Okay, so where's the on switch for this whole engine? Well, it all starts with one single thing, the reusable rocket. The source material calls it the gatekeeper, and that's the perfect name for it. It's basically the bouncer at the door to space. It decides who gets in, how often, and how much it's going to cost. Everything else depends on it. All right, the rocket unlocking orbit, and how one breakthrough changes the economics of everything above us. For so long, getting to space was like taking a one-way trip on an airplane that you had to completely junk after you landed. I mean, can you even imagine? Reusability. It's like we finally built a permanent, reliable bridge to orbit. And once you have that bridge, well, the entire game changes. And look at this number, 1%. We're not talking about a 10% discount or even a 50% off sale. We are talking about a potential 99% reduction in the cost to get to orbit. Seriously, just let that sink in for a second. It's like if a flight from New York to London suddenly cost $10. It's not an improvement, it is a total, complete revolution. And this really lays it all out, doesn't it? The before and after. On one side, you have the old way. Crazy expensive, you launch maybe a few times a year, and you can only send up these tiny, precious payloads. But now, we are entering the reusable era. Costs plummet, you can launch all the time, and you can send up massive amounts of stuff. It's the difference between a private members-only club and a bustling public highway. Okay, so here's the billion-dollar question. How does a cheap rocket launch actually make the AI on your computer smarter? It seems like a huge leap, but there's a clear chain reaction. Let's trace the dominoes as they fall. Okay, so here's the path, right? Step 1, rockets get cheap. That is the fundamental breakthrough. Step 2, suddenly, orbit isn't some exclusive destination anymore. It's wide open for business. Step 3, because it's open, you can launch huge constellations of satellites. Think Starlink. And once you have that orbital highway, you get to step 4. Putting data centers up there starts to make actual economic sense for the first time ever. And just so we're clear, this is not some sci-fi dream for the year 2050. This is happening now. Companies like SpaceX are already working on this stuff. And why? Because in the massive, high-stakes race for AI dominance, they think having data centers in orbit could be their ultimate trump card against the giants like Google and OpenAI. So we've seen the one-way path, but now let's zoom out a bit because this thing is way more interesting than just a simple chain of events. It's a full-blown network with connections going in all directions. Yeah, and this quote from the analysis really nails the other side of the story. It's not just that space is pushing new tech down to Earth. The demand from AI is so voracious. It's like a black hole for computing power and electricity. We're hitting real limits here on the ground, and that pressure is literally pulling the supply chain up into orbit. AI needs more, and space is becoming the place to get it. All right, so here's the whole system laid out in a table. Think of it as a loop. The rocket is the supply gatekeeper, right? It lets us build the satellite networks, which are the orbital backbone. That backbone supports space compute, which, along with ground compute, feeds the core driver of this whole thing, AI demand. And what powers every single step? Energy. It's the fuel for the whole shebang, on the ground and in space. Okay, so we have this amazing new engine. But just like any engine, it can get jammed up. There are critical bottlenecks, real choke points that could slow this whole thing down, or, if we solve them, could make it run even faster. So, what are the key factors we should be watching? I love this. This is basically our mission control dashboard for this new economy. These are the dials we need to watch. First, rocket maturity. Is something like Starship actually working as planned? What's its success rate and real cost? Then, space data center. Are they actually getting deployed up there? And back on Earth, ground power. What are electricity prices doing? Because if they spike, that could stall AI growth. You even have to watch the price of rocket fuel. Every single one is a critical piece of the puzzle. Now, this all sounds great, but let's be realistic for a second. There are huge risks here. I mean, what if the reusable rocket tech just isn't as cheap or reliable as everyone hopes? What if energy prices on the ground go through the roof and just choke off AI's growth? What if the whole business model for space data centers turns out to be a money pit? And, there's always the fun world of policy and regulation that could tie everything up in knots for years. So after all that, the risks and the potential, what's the big takeaway? What does the emergence of this new system actually mean for all of us? I think this is the single most important idea to grasp from all this. We really have to stop thinking about the space industry and the AI industry and the energy industry as separate things. What we're watching right now, in real time, is the birth of a single, unified space-ground economy. Progress in one place directly and immediately fuels progress somewhere else. It's all connected now. And this isn't some far-off future. The source material gives us a rough timeline. We're in the thick of it right now, in this 2026-2027 window, where the rockets have to prove themselves. If they do, then by the end of the decade, you could see a total explosion in launches, and space data centers could go from just a cool idea to a real business. And long-term, well, this whole network could just be how the world works, a fundamental part of our global infrastructure. So that leaves us with one last kind of mind-blowing question to chew on. The last big economic revolution, the internet, was built on silicon chips and fiber optic cables buried in the ground. Is it possible, just possible, that the next one, the next huge economic boom, is being built right now, silently, right above our heads, in orbit? That's something to think about.